Okay, so let's continue with the power law, and in these two examples, we're going to talk about solving, not evaluating. All right, so example number 3, I know to solve because they say to, but also because I have an equal sign, which makes this an equation, and I'm solving for a letter. Now, in solving, you can see it in two different ways. Your question could look like this, all right, in log form, or it could look like this, where you have, see it says solve still, and there's an equal sign, and I'm solving for a letter, but notice that there's no log anymore. So this is in exponent form. Okay, so in either case, how are you going to tackle solving questions? Well, let's go back to here. If it's in log form, change it to exponent form. If it's in exponent form, change it to log form. It'll help you to solve for your x. So let me show you. All right, here's log form, right? There's a log. And I'm just going to change it to exponent form by going 2 to the power of x is equal to 16. So something like this. So notice already, this is different than the evaluating stuff that we did before. Now, I can solve for x because I can make 16 match the 2. That's just 2 to the power of 4. Once the bases match, I can say, well, x must equal to 4. This indicates that your x is 4. Okay, so, I mean, that was fairly simple. Let's try it again. Change this log form to exponent form. X to the power of 2 is going to equal to 49. Okay, so right there. Now, I already know 7 squared is 49, but we got to do the work. Okay, show your work, don't guess. So get rid of that squared by doing the opposite, which is a square root. And the square root of 49 is your 7. Now, I know in the past I've always said square root of 49 is positive or negative 7, but remember, your x cannot be negative or a 0. This guy can also never be a negative or a 0 based on the log graph. Okay, so we're just going to be talking about the positive 7. X to the power of 1/4 is equal to 8. Okay, so there's your exponential form. Then this is a root, like a fourth root. Okay, so it might look like this instead. To get rid of that fourth root, you're going to have to do the power of 4. So these guys are opposites, they cancel out. But you got to do the same to the other side, and your final answer is x equals to 4096. Okay, you can always check it with your calculator by putting this number into here, and if you have that special button that allows you to input numbers here and here, see if your answer equals to 1/4. All right, now this question is the only one that's a little bit different. It has a coefficient. We're going to deal with it a little bit differently than we did in the evaluating examples. We actually have to get rid of it. Like, I want all of these log guys to be by themselves on this side. I don't want a coefficient in front. So let's bring the coefficient to the other side by dividing it. Okay, so you're going to get a 2 on this side, and the 3 disappears. Now let's put it into exponential form. 2 to the power of 2 is equal to x minus 1. If this is some sort of like a binomial or something like that, make sure you have brackets around it to indicate that the log of 2 is doing that to this entire thing. Okay. All right, so this is exponential form. That equals to 4. Okay, bring the 1 over, it becomes a positive 1, which adds, and you get a 5. All right, let's try that next example now. These are all in exponential form, so we have to put it into log form to figure it out, because I don't know what 1.5 to the power is to get 2. All right, so kind of like that warm-up that we did in the previous video, let's log both sides. Okay, so log of 2, log of 1.5 to the power of x. Now x is stuck all the way up here, so let's use that power law and bring it to the front. And it's going to be x times the log of 1.5. Now I can easily get x by itself by dividing the log of 1.5 out on both sides. All right, if you don't have a calculator, leave your answer like this. If you do have a calculator, you can calculate this divided by that one, and you get about 1.7. Okay, this question is a little bit different because notice that, I mean, there was only one base over here, and that's this guy right there, but there's this extra thing. So I need it to look like this, where it's only one number with the exponent. Let's get rid of that 25. You cannot multiply these guys together, BEDMAS. this has to deal with this first before it multiplies, right? Exponents first. So do not multiply these two before you have your exponent. Bring the 25 to the other side through a division. That divided by that is going to give you an answer of 20, and you're still going to have your 3x over here. This is what I want. I want just a number with its exponent. Now I can log both sides, okay, and then use the power rule to bring the x down, and it becomes a multiply. So x log 3 is equal to log 20. Get rid of that log 3 through a division on both sides, and then you get x equals to about 2.7. Okay, so hopefully you understand that when you're doing evaluating type of questions, you want the bases to match. When you're doing solving questions, you just have to switch it from log form to exponent form or the other way around, and then solve for your letter. Okay, the next video on 6.4 is actually going to be a little bit different, so why don't you check it out.